Welcome to Papa Junk Shop. Well, it's the next day. I got that heatsink and everything in the back all made, mounted on the controller. Had her hooked up for about a half an hour, and I got it set for I think 14.8 or 14.9 to cut off, and that's what it's doing right now. You can see it's, I hope you can see, it's kind of switching it on and off. And what I did is I just popped the fuses out of my solar panel and put it in where the fuses were going to be, because I wanted to be able to monitor it. And it's going to be kind of hard because it's a tight spot here, but that's what we got. 14.5 volts and 9 amps coming in with no load on it. The reason I got the voltage set so high is because those Edison batteries, they like a higher float voltage, charge voltage. So I'm going to turn my inverter on, which has about a 300 and some watt load on it. And this is the inverter. So it's drawing, what, 33, 34 amps at 13.3 volts at the present time. And the solar current went up to 21.1, which is probably about max, because we do have sunshine in today for a change. And down here you can see this is running 14.1 to, and the heatsink is just warm. Say I've been running about a half an hour. Now if I turn the inverter back off, we'll go up here and watch this, and as the battery voltage comes back up, you'll see it'll cut back. So it cut back, what, about 10 amps or so as it's charging the battery, and you see the battery voltage coming up. So it seems to be working. I'm going to leave it run all day today here, temporary, just to give it a fair shot. So I'll check in with you once in a while and tell you how it's going. I reset the thing for 13.7. I thought that'd give me a better idea under normal conditions for most people. And they do have it on a set of lead acid batteries. Been running about an hour. Still got what, 36, 37 amps on the inverter, and I've got, what, 22.8 at the moment there, and I've got 6 coming in there. So every once in a while it cuts back because battery voltage is up. And at one point when I looked, we got a gust of wind and the windmill kicked up, and it went right down to 0 for a short time because the windmill was making up for it. So the thing does seem to be functioning. You can see it switches back and forth amperage wise, cuts back once in a while. And I went and got, I forgot about my thermometer thing. See if I can run the camera and that at the same time. Heat sink's running about 100 and, yeah, 114, something like that, with that 22.9 amps on it. And if I shut the inverter off and it slacks back, of course the thing cools right down. So I think the heat sink is probably gonna make a big difference. When I printed the spec sheet out for the MOSFETs that's in there, the ratings on it were rated for mounted on a large heat sink. So I'll check back in later. Okay, it's about 12:30. About as good as we're gonna get sun-wise. So I was showing 24 amps, and then it went back to 0. So I got 24 amps coming in there, and I got 7 amps coming in there. And I measured the heat sink temperature, and it was 120 degrees. So, gonna leave her cooking, see if she'll take her. Well, the sun went away, and the wind started blowing. So I got to run it for a couple hours before the sun went away and the wind kicked up. And it seemed to do okay. The heat sink didn't get much above 120, even with that 24 amps in it. So I went ahead and put some permanent wires on it. We're going to let her hang there for a while and see how it does. So I'll let you know if it lets the smoke out or what. I got it tied into my panel here, and I got the 230 amp fuses on the solar coming in, and I got a 30 amp on the battery side of this thing. So if anything goes wrong, it should pop fuses. So if you enjoyed this one, give me a thumbs up, and if you haven't subscribed, please do, and we'll see you next time.